This is on Unit 1. We're starting here with 4.1 on factoring out the greatest common factor, the GCF, and grouping. So our video notes here are going to be in Part A, printing a monomial and greatest common factor. So in the first example here, we have a set of given values where our goal is to find the GCF, or greatest common factor. The greatest common factor is going to be the greatest or largest thing that divides into both quantities. So when it's numeric, we're looking for the biggest number that divides into 24 and 30. So I know that, for example, 30 is 5 times 6, and 6 goes into 24. So I think the greatest common factor is 6. If you're not sure what the greatest common factor is, what you can do is divide them out. For example, you can write that 24 is 6 times 4, and that 30 is 6 times 5. And so they have that 6 in common. You can tell that you have the greatest common factor because the two remaining factors don't have anything in common. If they did, like this was 4 and that was 8, for example, they would have 2 in common, so you knew that the one that you tried first wouldn't be greatest. So you want the leftover factors to have nothing in common. Oftentimes you can do it in your head for small numbers, but a calculator is handy for large numbers. You start with one number, find out what goes into it, and then look from there. So between 12, 15, and 20, I think between 12 and 15 it might have been 3, but 3 won't work with 20. Between 20 and 15 it might have been 5, but 5 won't work with 12. Excuse me. I'm recovering from a cold. Alright, now let's continue. So 20 and 12 again have something like 4 in common, but there's no number that all 3 of them share. 3 only works with the first 2, and so on. So the only number that you can divide into all 3 of those is 1. So the GCF is 1 for those 3 numbers. If you took any 2 individually, it would be higher than 1. However, for all 3 numbers together, 1 is the greatest common factor. Now for the rest of them, we're going to look at some sets that have variables as well as numbers. So you do those in 2 pieces. First, just the number. 9 and 15, I know I can divide them both by 3. That's the largest because it's 3 times 5 for 15. 5 won't go into 9. 5 doesn't break down. Then for the letters. The letters, the greatest common factor is going to be the largest variable because I know that a to the 5th is a times a times a times a times a. 8 seconds, a times a. There are at least 2 a's inside of a to the 5th, so it's going to be that one with the smallest power. It's going to be a to the 3rd, and again it's because a to the 5th is already equal to a squared times a to the 3rd, and a squared is a part of that. So it's always the smallest power for the variables. That makes it handy. So when I get to the numbers, and the next one, 8 and 24, I know that 8 goes into 24, so it will be the greatest common factor. 8 goes into 8, so that one will be 8. And for my variables, there are certainly x to the 5 in both of these. 7 is bigger than 5, so this is 5 and 2 for 7, so we have x to the 5th. And we'll summarize that again in a moment down here for variables. Alright, 6, 10, and 15. I can divide by 2, doesn't work. Divide by 3, doesn't work. There's no number. 2 and 3, the only things besides 6 and 1 that go into 6. 2 and 3 don't work for both of those. 6 doesn't work for both of those. It's just 1. Those are my thought processes for that one. And then n to the smallest power, 4th. So 1 n to the 4th, 4. You can just write n to the 4th. You don't have to write the 1. And then for the next one, 4, 6, 8. The smallest number of 4 goes into all of them, so we're going to keep the 4 as the numeric greatest common factor. For the variables, x, there's at least one x in all of them, and y, there's at least y squared in all of them. And the last one. Okay, so this one is about the negative right here. If the greatest common factor of one of them is negative, you're going to want to factor out the negative, usually if it's the highest power. So because there's a negative on the highest power, that negative is going to go with the greatest common factor. There's no numeric factor here. There's the invisible 1, so I'm going to keep a 1. And then for my smallest variable, we're going to have the x. So negative 1x, or just negative x is our greatest common factor there. Okay, quick little summary. How to find the greatest common factor. So it depends on what you've got. So if you're looking at numbers, you're looking for the largest number, the largest value that divides evenly in. To all numbers. Okay. If you're looking for negatives, you want to keep the negative if you have the negative on the higher power. So factor out a leading negative. Leading terms are the terms with the highest power, so we're going to always factor out a leading negative, or included a leading negative. How about that? Because we're looking at not factoring quite yet. We're getting to factoring down here. But we're going to be looking at how to identify the greatest common factor is you need to have a leading negative. So a leading negative, leading again means on the highest power. Doesn't matter if everything else is positive, if that first or highest power term is negative, you're going to take that leading negative out when you factor. Oops, power. All right, and for variables, the most that they all have in common is the same as the lowest power. And that can be up to more than one variable, like we saw in the one that had the x's and the y's. 1x was the smallest amount of x's, and then 2y was the smallest amount of y's, so we included x, y squared. Now to actually do some factoring with these, looking at the next one, how to factor out a greatest common factor of a polynomial. I'm going to find the GCF first, write it down. Using parentheses, write down what is left once you factor, and again, factor means, divide. Remember, factoring is the opposite of the distributive property. So the distributive property is multiply, factoring is divide. So our goal here is to have something that looks like it hasn't been distributed yet. All right, so we've got this one broken down. I want to first find the greatest common factor, and our greatest common factor is going to go outside the parentheses, and what's left inside the parentheses will be the result after dividing this out. So 20, 12, and 28, look at the numbers only first. 20, 12, and 28 can all be divided by 4. And then any variable they all share, we get to join them. There isn't one. Negative, the leading term isn't negative. Now that highest power doesn't really apply when you have multiple variables, so we'll go for the first term. So that's going to say just a regular 4. Now I divide that out. So what's left, 20 divided by 4 is 5x, 12 divided by 4 is 3y, and negative 28 divided by 4 is negative 7z. Okay. One other thing I want to point out is that the original has 3 terms, which means that the inside of the parenthesis must have the exact same number of terms as the original. When you distribute this outer term back in, you would get those 3 terms from the original. The inside is 3 terms matching the original. Okay, and the last one right here for our video notes. I see first that I have a leading negative, so we're going to factor out a leading negative. So my greatest common factor is going to be negative. Then I'm looking for my number, 15 and 25. 5 is the greatest number that divides into both of those. Then my variable component, the least number that any variable has is x squared, so 5x squared, that's all the greatest common factor. So I write my greatest common factor outside of parentheses. Now I start my parentheses, divide it out of each term. So out of the first term, negative 15 divided by 5 will be positive 3. And then I have x to the third divided by x squared, 1x left. We took 2 out, there's 1 remaining. Minus 25, or negative 25 divided by negative 5. Negative divided by negative will be positive 5. So you have to watch your signs carefully. Dividing a negative by a negative makes it a positive. And then you took out 2 x's, or x squared, and x squared was what we had, so you have none remaining. Close your parenthesis. You can always check these by going back and distributing to make sure that you have the original.